Hello students, it's Nazia Begum here, your physics lecturer, welcoming you all in today's class and wishing you all a very happy new year. I hope that this wish will not prove false like the last year when all have congratulated everyone for a happy new year and the year was not at all happy. I really hope that this year would be a very happy one and remove all the, we can't say that remove, but it will create good memories. Okay, so now let's move to today's topic, that is latent heat. So first of all, let me tell you that whenever heat is supplied to any substance, what happens to the molecules? So whenever heat is supplied to any substance, the molecules of the substance, they capture the heat and they become very active. Okay, they get excited, they start vibrating, and if more and more heat is supplied to them, then after getting excited, after vibrating at their own position, they start changing their position. Okay, the force of attraction between them becomes less, it starts decreasing, and because of that the molecules start going away from each other. So in short, whenever we give heat to any substance, the molecules of the substance starts going away from each other, and when molecules goes away from each other, okay, so that time what happen, the state of the substance gets changed. Okay, and just reverse thing happen when the heat is taken away from any substance. If the heat is taken out from any substance, the molecule starts coming close to each other, that also causes change in state. Okay, so whenever heat is supplied to any substance or whenever heat is taken out from any substance, it causes change in the state of the substance. Okay, so whatever amount of heat is required for a substance to change its state is called the latent heat. Okay, suppose we are having a unit mass of ice and we are giving it heat, the ice will convert into water, the state will change. So whatever heat is required to convert that whole ice into water will be the latent heat of that ice. I hope now the concept of latent heat is clear. Okay, so here the definition is written. From here you can see, latent heat of a substance is the amount of heat required to change the state of unit mass of the substance, to change the state. Okay, so solid, liquid or gaseous, whatever state is there, if we want to change the state, we have to give heat, and that is called the latent heat. Suppose heat Q is required to change the state of mass m of this substance. So Q will be given by m into L, where L is the latent heat of the substance and m is the mass. Okay, so from this equation we can get formula for latent heat, L equals to Q upon m. The SI unit of latent heat is joule per kilogram. Depending upon the transition from solid to liquid or liquid to vapor state, latent heat can be of following two types. First, latent heat of fusion. The amount of heat required to convert unit mass of a substance from its solid into the liquid state is called latent heat of fusion or melting. From solid to liquid is called fusion. Okay, and one example is given here. Latent heat of fusion of ice is given 3.3 into 10 to the power 5 joule per kilogram or 80 calorie per gram. Then latent heat of vaporization, it is defined as amount of heat required to convert unit mass of a substance from its liquid into vapor state. Latent heat of vaporization of water is 22.6 into 10 to the power 5 joule per kilogram. So if we are having 1 kg of water, to vaporize that water, how much amount of heat we will need? We need 22.6 into 10 to the power 5 joule of heat. And here in front of you, you have one graph which is showing different points for water. Okay, first you can see melting point, then boiling point. Okay, so in this graph, at x-axis we have taken time, at y-axis we have taken temperature. Okay, so 0 degree centigrade is the melting point. Below 0, water will be in solid state, that is in form of ice. At 0 degree it starts melting. Okay, then this melting point continues some time, and then if we increase the temperature of the water to 100 degree centigrade, so at this temperature the water starts boiling, that means it converts into vapor form. Now let's start next topic, which is heat transfer. Okay, so heat is a form of energy, and like we all know that energy changes its form. Okay, and also we know one basic rule, that energy transfer from one place to another, and there are various modes of transfer of energy. Okay, so here we will see that how the energy is transferred. Heat energy is transferred from one place to another place, or one point to another point. So here basically three modes of transfer of energy are there. First is conduction, second is convection, and third is radiation. Okay, so let us first understand what is conduction. Now suppose you are having one rod. Okay, two ends are there of rod, A and B. Okay, now suppose you start giving heat to end A with the help of a burner. You start giving heat to end A and you hold the rod from end B. So after some time, what you feel, that we are giving heat to one end. Okay, we are giving heat to one end of the rod, but after some time what you feel, that at the second end also the temperature has increased. That means the amount of heat has transferred from point A to point B. So in this case what happened, the heat actually not come here. Okay, means the source of heat has not came here. The source of heat was at its particular place only, but the heat energy has transferred from point A to point B. Okay, and when it has transferred from point A to B, there is not actual motion of particle. Okay, that means initially we are having the rod. Okay, and after the transfer of heat also we are having the same rod. Each and every particle of the rod are at their own original place. There is no motion in the molecule or particles of rod, but the heat has transferred from one place to another place. Now I will explain you how this happened. So now we will see the internal structure of the rod. Suppose this is the rod. Okay, and inside the rod so many molecules are there. Okay, let us consider some molecules inside the rod. Okay, so at point A we start giving heat energy. After getting the heat energy, this molecule become excited and start vibrating. When the molecule vibrate, it vibrate on the both side. Okay, and in course of its vibration it transfers some of its energy to the other molecule. Then this second molecule starts vibrating by getting the energy. When the second molecule vibrate, it also transfer its energy to the third molecule. So like that, I hope now you understand that here actual motion of molecule does not take place, but molecules simply transfer heat energy from one molecule to another molecule. Okay, so here at point A, one molecule was getting energy, and that energy is transferred to another one, then the next one, and then the next one, and like that the heat energy has transferred from point A to point B. Okay, you can imagine the case that when the laborers, when they are doing any construction work, okay, and they have to parcel bricks or cement, etc. So you can see that they stand at a particular separation, okay, next to each other, and whatever material they have to transfer from one place to other place, they simply give that material to the next labor which is standing in front of them. Okay, and like that that material is transferred from one place to another place. You can also imagine one more example, that you are sitting in first bench, your friend is sitting at last bench, and you have to give pen to your friend. So you simply not stand up and go there, but you pass the second bencher, then second bench one will pass it to third bench. Okay, so like that one by one you pass your pen, okay, and the pen finally reaches to your friend. So like that here, in case of conduction, there is no actual motion in particle, but only the heat is transferred from one particle to another particle, and like this the heat transferred from one place to another place. So here you can see definition of conduction. It is process in which heat is transferred from one part of a material medium to another at lower temperature without physical movement of the heated molecules or atoms. Okay, and example I have already explained you. So now let's move to second mode. So second mode of transfer of heat is called convection. For convection, let us again try to understand it with one example. So suppose you are having one container. In this container water is filled there. Okay, in this container water is filled, and with the help of a lamp you start giving heat to the water. Okay, and after some time what you will observe? You will observe that some bubbles are created at the bottom, and that bubbles are going in upward direction. Okay, this thing you will observe. Nowadays as winter is going on, so when those who are using geyser, they will not observe that, but those who are using that immersion water heater, okay, water heater, so you will notice that when the water is when the temperature of the water started increasing, so that time you notice that some bubbles are coming from the lower part of the bucket, from the lower part to the upper part. Okay, and whenever you are cooking something and you have to make the you need hot water, so that time also you see that when you give heat to water, so the bubbles are coming up. Okay, from the bottom the bubbles are coming up. Okay, so that is also a kind of transfer of heat. Actually in case of fluid, what happen, all the fluids, in fluid, what is the definition of fluid? Anything which can flow is called fluid. So liquids as well as gas, they are considered as fluids. So one property of fluid is that whenever heat is supplied to fluid, they move in upward direction, they become very light and they start moving in upward direction. Okay, so here in case of water or in case of any fluid, what happen, whenever we give heat, okay, the molecules absorb that heat and that molecules go up, and when the molecules go up, their place becomes empty. So at that empty place, the cool molecules whose temperature is less, they come down and take their place. Okay, so like that this continuous motion goes on. The hot molecules, they go up, okay, and the cold molecules, they come down, and like that the whole cycle works, and whatever fluid we are having, its temperature gets heated up. Okay, so this is also a kind of transfer of heat, which is there because of the motion of the particles, motion of the molecules. Okay, and this is called convection. So in conduction there was no physical or actual motion of molecules, but in case of convection there is actual motion of molecules. Okay, so here let's read the definition now. It is the process in which heat is transferred from one part of a medium to another due to the physical movement of the heated particles. Thus, convection is the process of heat transfer by the actual physical motion of the matter. It can be both the natural or forced. Some familiar phenomena that occur due to natural convection are discussed as under. Okay, so some natural examples we will see now. Heating of a fluid. When a fluid is heated in a container, the particles at the bottom get heated. As a result, the density of the fluid decreases, so it rises upward. Hence, the cooler fluid from above, being denser, moves downwards to receive the heat. And this thing I have already explained you. This process continues, resulting convection currents in the fluids. Okay, so in that example I have told you that in the pot in which water was filled, okay, the hot water goes up and the cool water comes down. So there is motion of water, okay, and that is called current. Okay, so convection current starts whenever the fluid is in motion, that is called current. Okay, or not only fluid, when anything is in motion, so we can call it current. So there the convection currents starts. Some more example of conventions are given here. For second one is trade wind. During the day, the equatorial regions of the earth receives more solar heat than the polar region. Okay, so you can understand it by this. This is earth, and suppose here is sun. Okay, and sun rays are coming towards earth, and this is the equatorial plane. Okay, and these are the poles. Because of the structure of earth, the poles receive very less energy of sun. Okay, some amount of energy goes like this, and very less energy they receive. But the equator receives very high amount of energy because it is directly exposed to sun. So that's why what happened, the temperature near the equator rises more in comparison with the poles. And because of that, what happened, the convection currents are set up from equator towards the poles, and cooler air moves downwards from the poles to the equator. Okay, the temperature at equator rises, so that's why the hot airs starts moving from hot region to cold region, that is from the equator to the poles. Okay, and the cooler air, they start moving from downward to downward direction, upward to downward direction, that is from poles to equators. Okay, and when they are coming down, okay, once again let me show you with diagram. So this is earth, okay, and this is equator, these are poles. From equator hot airs are going up, okay, and from poles cold airs are coming down, cooler airs, okay, they are coming down. So when they are going up or coming down, so it is not like the earth is static, earth is also rotating. Okay, so they are going up and earth is also rotating, so that motion of air is not completely vertical. Okay, the air is not completely going upward or coming downward, it is not vertical because of earth's of rotation of earth, and the air earth is a little bit tilted also. Okay, so that's why what happened, the air descends at 30-degree latitude and moves back to the equator. The surface wind on the earth that blows from northeast towards the equator is called trade wind. Then next is sea breeze. During the day, the solar heat is absorbed more quickly by the ground than water in sea. As a result, air in contact with the ground becomes warmer and lighter. Hence, the warm air rises up and the cooler air from above moves down to fill the space. These convection currents are set up which takes the heat away from the ground. This is called sea breeze. In forced convection, the particles of the medium are forced to move using a pump or by other some physical means. Okay, so some familiar examples are circulation of blood in human body through the heart, cooling system of automobile engines, and air heating system in homes. So today we have discussed two modes of transfer of heat, that is conduction and convection. In next lecture we will discuss radiation in detail. Okay, so this is it for today's lecture. See you in next lecture. Till then, goodbye, take care, do some productive work, and the most important thing, be healthy, be safe.